Okay, guys, yesterday we talked about the law of sines, where you needed one angle and its corresponding side length to figure out the measures and everything of side lengths and then angles inside. There is a case when you're using the law of sines that's called the ambiguous case. All right? The ambiguous case is a unique triangle that has one solution, but another one could be possible with the given information. And I'll show you what I mean by that in a second. It's when you're given two sides and one angle that's outside of the side, like two sides and then an angle on the outside. There could be two triangles. There could be one triangle, two triangles, one triangle, or no triangle. Remember, in the no triangle, it's when you put it in your calculator, it'll tell you error. And then we'll figure out how to determine between 1 and 2 here in a second. These are what the pictures look like. I'm not super concerned about you guys because you don't have to draw them, but just understanding. But here, all right, what do you notice about this problem? It has a radical. This is a 45, 45, 90. This is a special right. We're going to have special right stuff on your test, but we're not going to get to that till probably next week or so. But if you have a triangle, and we're going to draw it, just draw your arbitrary triangle, A, B, and C, right? A, B, and C. They tell you that angle A is 45 degrees. They tell you that side A is 7 square root of 2, and side B, so across from B, is 7. All right, this is in radical form. You can go ahead and change it to decimal as we work through. I just want to talk about this. I want to know, it says to solve the triangle. So what are the pieces that we're missing? We're missing what? We're missing side C, so little c. What else? Angle B. And we're missing angle C. All right, now this will only occur, guys, the possibility of those three when you're using law of sines, when you're given two sides and an angle. If they give you two angles, there cannot be a second triangle. So in this case, you would set this up and you would say sine 45 over 7 square root of 2, right, equals sine of B over 7. You guys agree? Because we're looking for angle B. So when we cross multiply, you have the sine B times 7 square root of 2 equals 7 times the sine of 45. Divide both sides by 7 root 2. Go ahead and do it in your calculator. So you get the sine of B equals, I have 7 sine 45. My calculator just ran out of batteries. Anybody?
I should get my
The whole number 1?
Yeah.
Okay, so you got the whole number 1. So then what is second sine, second answer? What's angle B? Okay, angle B is 90 degrees. So this is a 45, 45, 90. So if this is 90 degrees, what do you know angle C is? 90 degrees, or 45 degrees, sorry. And what do you know about 45, 45, 90? Both the legs are the same length, all right? That's our special right triangle. But there's only one triangle present here. When we go to do these other questions, you're going to have the possibility of a second triangle. And I'm going to show you exactly how to do that. But that works out that way because it's a special right. All right, so let's move along here. I want you guys to see, we'll talk about this. It says in general, you're going to find, you need to subtract from 180. I'll show you what I mean by that in a second. So let's just do some examples, all right? This is a case of two solutions. It tells you that there's two solutions. You always have to check for two solutions if you have two sides and an angle. If you have two angles and a side, you don't have to. But let's draw a picture of what we're working with. Right? A, B, and C. They tell me that angle A is 43.1, okay? They tell me that side A is 186.2 and side B is 248.6. So, in order to solve this triangle, whenever you're using the law of sines, you always need to say, okay, hey, here's triangle 1. And what's the possibility? You could have triangle 2. You may not, but you might. So when you are doing these questions, you do this every single time. Look at what's given. Whatever is given in the triangle, if there is a second triangle, that will be given as well. So what's the given angle? Angle A, right? So if they give you angle A is 43.1 degrees, if there's a second triangle, angle A will be in that triangle as well, 43.1 degrees. So we now need to find what 2 other pieces of information? Angle B, angle C, and side C, right? If there's a second triangle, we'll find that in there as well. This is how you do that. Whatever the given angle is, perfect. Write it in both triangles. So how would we figure out angle B? With the given information in our triangle, what would you set up? Sine what? Sine 43.1, good, over 186.2 equals sine of B, I don't know what it is, over 248.6. Exactly what we did yesterday, right? So now we cross multiply. So you have 248.6 times the sine of 43.1 equals 186.2 times the sine of B. Agreed? We're going to divide both of these by 86.2. 186.2, I should say. So I get the sine of B equals, do that in your calculator, so 248.6 times the sine of 43.1, and then divided by 186.2. You get something like 0.912254. So second sign, second answer. And you get 65.8 degrees. Everybody with me? Okay, 65.8 degrees. All right, this is nothing new from yesterday. Now, to continue figuring out the rest of this triangle, how would you figure out what angle C was in triangle 1? Add and subtract, okay? Here is the difference. Here is how you find if there's a second triangle or not. You're going to find the supplement of the angle that you found. What does supplement mean? 2 angles are supplementary. They add up to be what? 180. So here you're going to say 180 minus 65.8. So 180 minus 65.8. What do you get? 114.2 degrees, correct? Now, if a second triangle exists, this is how you'll know. Add up these 2 numbers. 114.2 plus 43.1. What do you get? 157.3. How would you figure out what angle C was? Yep. If this number, when you add these 2 together and it's less than 180, then yes, there's a second triangle. So minus 180. This angle is 22.7 degrees. Then there would not be a second triangle, correct? Say you got 195, that means, whoops, there's not enough for a second triangle. So now you're going to do the same thing over here. Add up these 2, so 43.1 plus 65.8. I get 108.9. So 180 minus 108.9 is what? 71.1. Perfect. Now you can find side C in both of them. Use the information from triangle 1 to find C in 1. You find the information in triangle 2 to find C in triangle 2. But what stays the same is that first, this right here, this first given information. That was our law of sine proportion. For triangle 1, I'm going to say, okay, sine 43.1 over 186.2 equals sine of C. What's C in triangle 1? 71.1 over little c. For triangle, this is for triangle 1. For triangle 2, I'm going to do the same thing. Use that same proportion because remember, whatever is given to you is in both triangles. In this case, we're going to say the sine of what was C in this one? 22.7 over little c. So all it is once you put the given information down, right? Given, you're good to go. Then once you find your first angle, you just find the supplement. If it's less than 180, then a second triangle exists. If it's more than 180, then it doesn't. We're going to do some more. So 186.2 here times the sine of 71.1. Hang on one sec. Equals C times the sine of 43.1. And then divide both sides by sine 43.1. Question? Sure. So in triangle 1, what does little c equal? 186.2 times the sine of 71.1. And divide that by sine 43. What'd you guys get? 257.8. Okay. So little c up here is 257.8. Now we're going to do the same thing, use the same first given proportion, but you use the angle C information from triangle 2. So 186.2 times the sine of 22.7 equals C times the sine of 43.1. Divide both sides by sine of 43.1. And little c over here equals, again, 186.2 times the sine of 22.7. Divided by sine 43.1. What'd you guys get? What'd y'all get? $105.2? Yes or no? Okay, so 105.2. We're going to do some more examples, but the way that you do this, guys, if you're given two angles, there's only one triangle that can be available because you're going to add those two and subtract. But if you're given one angle and two sides, then you could say, well, let me check and see. Is there enough degree measure left over with the information given to form a second triangle? Let's look at this one. Obviously, it says what this is, and then we'll do some that doesn't tell you what's going on. But draw your triangle. All right, angle A, I got B, and I have C. So A is 42 degrees. Side A is 70, and side B is 122. So I'm given two sides and one angle, correct? That means I could have a possibility of two triangles. I could also have the possibility of just one, or I could have the possibility of none. But I can use the law of sines. What was I given? What is the given information in both of these? What's angle A? 42 degrees. So write that down for both triangles. Angle A in both triangles is 42 degrees. So I'm going to say, okay, so sine 42 over 70 equals sine of what angle over 122? Sine of B, because that's what's across from it. So cross multiply. 70 times the sine of B equals 122 times the sine of 42. And divide both sides by 70. So 122 times the sine of 42 divided by 70 gives us what? 1.166199, something like that. So second sign, second answer. And what do you get? You got an error message. You got that error message. If I get that error message, what is that information telling you? There's no triangle. And that's exactly how you can answer it. Don't write error. That doesn't mean anything to me. That means you don't understand what that error message means. If you get an error message, that means, oh, wait, there's not a triangle. Look at these two. All right, it's just going to tell you to solve the triangle. So if I don't see a picture, what should I do? Let's draw one, okay? So just your arbitrary oblique triangle that has three corners, no right angles. Angle A, they told me, is 70. Side A, 25. And then side C, 26. So across from angle C is side C. So set up the possibilities. What are the possibilities that could be here? You could have one triangle You could have two triangles or you could have no triangles, but go ahead and get ready. The reason that is the case is because you have two sides and one angle. So whatever is given in the first triangle, if there is a second triangle, will be given there as well. So go ahead and write down, in this case, 70 for both angle A's. So your law of sines proportion that you're going to start with is sine of 70 over 25 equals, what's the sine C? The angle we're finding here is C. So we're going to cross multiply. So 26 times the sine of 70 equals 25 times the sine of C. Divide by 25. So the sine of C equals, what's 26 times sine 70 divided by 25. 0.97728. All right, second sign, second answer. 77.76. Let's just round it to the nearest degree. So 78 degrees. So here in triangle 1, we said angle C is 78 degrees. Now you guys could continue this. And you could now find angle B. How would we find angle B? You add 70 and 78. You get what, 148? What's 180 minus 148? Angle B is 32 degrees. You guys okay with that? And then what side are we going to find? We'll find side B. We'll do that in a second. But we have to check to see if a second triangle exists. How do we do that? Well, you take the one that you just found and you find its what? Supplement. How do we do that? 180 minus 78. So what's 180 minus 78? 102? You guys agree with me? Okay. 102 degrees. Now, I still don't know yet if there's a second triangle. What do I have to do to figure out if there's a second triangle? We're going to add these two. What's 102 and 70? 172. Is that less than 180? Yes. If I said 180 minus, I have some degrees left over. What is that degree measure left over? 8 degrees. It's tiny, but it's there. So then you know you're going to have to find side B over here as well. So again, go back to your original law of sines proportion that you had. 70 degrees and 25. So on the left-hand side here, I'm going to say sine 70 over 25 equals sine of angle B in triangle 1 is 32 over I don't know what the side is. In the second triangle, same thing, because whatever's given to you is true in both triangles. So sine 70 over 25 equals the sine of 8 over little b. And we're going to solve each of those. Cross multiply. So you have 25 times the sine of 32 equals b times the sine of 70. Divide both sides by sine 70. And how long about is side B? 25 times the sine of 32 divided by the sine of 70. About 14.1. So we'll say about 14.1, okay? So B over here is about 14.1. And then we're going to do the exact same thing over here. Same information, just different triangle. So I have 25 times the sine of B. No, I'm sorry, that's an 8. Equals B times the sine of 70. Divide both sides by sine 70. And little b on this side is 25 times the sine of 8. Divided by sine 70. 3.7. So little b over here is 3.7. So in this case, guys, there were two triangles present. Whatever is given in the first triangle, if there is a second triangle, will be the same as well. So you find that angle, you find the first angle that you're looking for, then you take the supplement, see if there's a second triangle. Let's look at this next one. All right, again, draw your picture. A, B, and C. All right, they told me angle B was 45. Side A is 28, and side B is 27. So do I have two angles and one side, or two sides and one angle? What they gave me, 2 sides and 1 angle, or 2 angles and 1 side? 2 sides and 1 angle. That means I could have 2 triangles. So I'm going to go ahead and write down, all right, if I have 2 triangles, let me go ahead and set it up. If there are 2 triangles, angle B in both of them will be 45 degrees. So look at your law of sines proportion that they gave you. 45 degrees and 27. So I'm going to say sine 45 over 27 equals. What angle am I finding? A, sine A over 28. So in this case, I'm seeing angle A, what it would be in both triangles. So cross multiply. 28 times the sine of 45 equals 27 times the sine of A. Divide by 27. Sine A equals 28 times the sine of 45. Divided by 27. What do you guys get? 0.73329. So second sign, second answer, and I get 47 degrees. You guys agree? Okay, so 47 degrees. So if there is an angle A in a second triangle, how would I figure out what that measurement was? I'm going to say 180 minus 47. Well, 180 minus 47 is 133. All right, do I know yet if there's a second triangle? Not yet. How do I figure out? Add these two. What's 45 plus 133? 178. God bless you. 178. Is that less than 180? It is. So is there a second triangle present? Yes. What is the angle measure of this last little angle? 2 degrees. It's teeny tiny, but it's there. How do you find the measure of angle C over here? What do you do? 45 plus 47 equals 92 minus 180, 88 degrees. If I added up and this number over here was bigger than 90, you would say, oh, well, never mind. The second triangle doesn't exist.
Did you get 88?
I added these two. So 45 and 97 and got 92, and then just said 180 minus 92. Yeah. So now we need to find little teeny tiny c over here and little teeny tiny c over here. And again, go back to your original law of sines proportion that they gave you. My original proportion was sine 45 over 27. So I'm going to use it in both triangles, because whatever is given in the first triangle is true in the second triangle. So if I'm trying to find side C, I have to use the angle C measure. So it's going to be in triangle 1, sine 88 over little c. And in triangle 2, it's going to be the sine of 2 over little c. And then we're going to cross multiply. So 27 times the sine of 88 equals c times the sine of 45. Divide both sides by sine 45. And in this triangle over here, 27 times the sine of 88 divided by sine 45. 38.2. You guys agree? Okay, 38.2. And then over here, again, cross multiply. So 27 times the sine of 2 equals c times the sine of 45. Divide both sides by sine 45. So little c on this side is 27 times the sine of 2 divided by sine 45. 1.3. Okay, teeny tiny. That's fine. All right, so to recap, any information that is given to you about a triangle, if a second triangle is present, it will be, that same information will be in the second triangle. So whatever angle they give you in triangle 1, if there's a second triangle present, it'll be in triangle 2. So find the first angle you're looking for after the given. Then you take the supplement of that to determine if a second triangle is there or not. Does that make sense? Okay.